Okay, in this video we're going to be discussing what complex numbers are and how we can use them on the Argand plane. So since primary school, we've always learnt of the number line. The number line consists of every single countable number you can think of, all the way from negative infinity all the way to positive infinity. And this includes both rational numbers and irrational numbers, such as square root of 2, it includes pi, it includes e, it'll include fractions like 2 over 7, etc. Every single number you can think of will exist on this number line. Okay, so 1, 2, 3, 4, 5, you get the idea, every single number. But now we have what's known as an imaginary number. And for the purpose of this video, we're going to say that an imaginary number is really just the same as I. Okay, and what is I? What is the imaginary number? Well, the imaginary number is the square root of negative 1. Okay, and I don't expect you to be completely confident and okay with me saying that the square root of negative 1 is now just called an imaginary number, but for the purpose of this video, it just is. Okay, the square root of negative 1 has some useful benefits, which I'll cover in different videos, but for now, we're just going to denote this as I. So I is the same as the square root of negative 1. But we've always learnt that the square root of negative 1 is, you can't evaluate this. There's no real number or counting number that you can think of which actually lies on this number line. So what do we do with this? Where does this fit on our number line? There's no place for it to slot in, right? Well, that's why we have what's known as an Argand plane. Okay, we have what's known as an Argand plane. And our Argand plane is really just the number line with an added axis to it. So it'll look like this. Okay, so now we have created a separate axis for where our number line can exist. And what you notice is these are all your counting numbers. These are all your imaginary numbers. And it'll go up in counting axis like the same way. So it'll go 1, 2, 3, 4, etc. And it'll also go back down the other way. So -1, -2, -3, -4, and etc. Okay? And we can see if we want to plot the number I on our number line, well, that number would simply just exist over here. Okay? The reason for that is our x-axis, we're going to call the real number line. So think of the real of z as the real numbers for the complex number z. Okay? And the real numbers are just any counting numbers that you can think of, whether it be pi, whether it be e, whether it be I, whether it be fractions, whether it be decimals, whole numbers, integers, real numbers, you get the idea. But on this axis, we're going to have our imaginary axis. So we're going to write over here the imaginary component of z. So this will include every number to do with I. We can include pi I, we can include 2i, we can include the square root of 4i, square root of 5i, any number to do with I will exist on this number line here. A complex number, okay, so we know what an imaginary number is. We also know what our Argand plane is. Okay, but what's a complex number? A complex number, okay, complex number is one which has both a real component as well as a imaginary component. So in this case, we're going to call our imaginary number z. Okay, so z equals to a plus bi. That's why I've said the real component of z and the imaginary component of z, because z is called our complex number and it has two components. It has a, it has b. So in this case, a is really just your real component, so this number will exist on this axis. And then b is your imaginary number. Okay, so this is your imaginary component, and that number will exist on your vertical axis. You can think of this as coordinates on a Cartesian plane, where this is your x-axis, this is your y-axis, and then you'll have coordinates a, comma, b that lie on your plane somewhere. Okay, so now that we have these terminologies written down and known, let us now go through a few problems. Okay, here's our first question here. We have 1, 2, 3, 4, 5, 6 dots on my screen, and our goal for this question here is to work out what is the complex number that will represent each of these points. Okay, and more specifically, the complex number is written in Cartesian form. So remember, Cartesian form is really when a complex number is written as a plus bi. So it's Cartesian form because you're telling me both the x-axis value, or the real component of z, as well as the y-axis value, or the imaginary component of z. So this is called your Cartesian form. So let's have a look at the first point here. Okay, we're going to focus on this point here. We can see that we're moving 3 units across on our real axis, and then we're moving up 1 unit in our imaginary axis. So you can kind of see this as me saying, if it's in the form a plus bi, then your real component is really just 3, because you're moving 3 this way. But then your imaginary component is 1, because you're moving up by 1 unit. So we can say this complex number over here is really just the same as 3 plus 1i, or just 3 plus I. So that's how you work out the Cartesian point, the coordinate, Cartesian coordinate of this point here. Now let's have a look at this one here. Okay, it's the same principle. We've moved 2 across in our real axis and 2 down in our imaginary axis. So this coordinate will be 2 take 2i. Then this point here, we can see we're not moving anywhere left or right on our real axis, but in our imaginary axis, we're moving up by 2 units. So we can say this here is really just the same as 0 plus 2i. And the 0 denotes that we haven't moved in our real axis. So we can also just write it as 2i. Okay, just plain and simple, 2i. Now let's have a look at this point here. We've moved minus 1 units to the left and 1 units down. So this would be the same as minus 1 take I. This here, it would be the same principle as our 2i point. We've not moved up or down on our imaginary axis, but we have moved on our real axis. So this number is just the same as minus 3. Okay, and you can say it's plus 0i, but there's really no need for that. You can just say it's minus 3. And our final point is this one here. We've moved to the left by 3 units. We've moved down by 4 units. So the coordinates, or the Cartesian coordinates, is minus 3 take 4i. And that's how you represent Cartesian points, Cartesian coordinates of complex numbers on an Argand plane. Okay, this is our next question here. We've been told that a complex number z1 is 6 take 5i, and the complex number z2 is minus 3 plus 4i. And our goal is to work out both of these values here, so the 2 complex numbers added together, and the 2 complex numbers subtracted from each other. And we also have to plot these 2 points, all 4 of them actually, whatever we get, on our Argand plane. So let's have a look at that now. Let's first plot these 2 points here. So in this case, 6 minus 5i. Okay, that's the same as going 6 units in our real axis and then 5 units down. So that's actually off my axis here. So I'm just going to put that point over here-ish. So 6 units is over here and minus 5 is roughly here. So I'll say this is z1. Okay, so now that we have this, let us plot z2. z2 is minus 3 plus 4i, and that does lie on our axis. So minus 3 plus 4i, that would be right about there. So that's z2. So let us now calculate how to add 2 complex numbers. We can add 2 complex numbers by simply adding their real parts and then adding their imaginary parts together. So in this case, 6 take 5i plus minus 3 plus 4i. We can group the 6 and minus 3 as minus 3. So, plus 3, so 6 take 3 is plus 3. And then minus 5i plus 4i is the same as minus I. So the answer to this one here is simply the same as 3 take I. And now, if we wanted to have a look at this one here, we can see that z1 takes z2. We can do the same principle. We can just do the real components minused away and the imaginary components minused away. So in this case, 6 minus minus 3, that's the same as 9. And then minus 5 minus 4, that's the same as minus 9. So our complex number is 9 minus 9i. Okay, and both of these, well, this one here lies on my axis, so I'm going to sketch that one. So 3 take I is just the same as what's over here. So this is the same as z1 plus z2. But then this complex number, 9 minus 9i, that lies somewhere over here. So it's 9 units this way and then 9 units down. So that point would actually lie over here. That's what z1 takes z2 would be. But because it's off my axis, I'm not actually going to include it. But that's how you add complex numbers together, and that's how you can add the points on your Argand plane.